Assalamu alaikum. Yes, children. From the last exercise of triangles chapter 1, question was left last time. We'll first complete that last question of the triangles chapter, and then we will begin today new chapter. We'll start quadrilaterals chapter today. So we'll begin first that last question, question 6 of the triangles chapter. With that, our triangles chapter will come to end. The statement of the question reads, show that, we have to prove that, what we have to prove, of all line segments drawn from a given point, not on it, the perpendicular line segment is the shortest. Here the statement misses some words. Some words are missing there. You will have to use those. I shall tell you where. Show that of all line segments drawn from a given point. Here you have to add few words to a given line. From a given point to a given line. These words are missing there. You will add those there. Not on it. You will then put in the brackets. So the statement will go like this. Show that of all line segments drawn from a given point to a lines, then bracket has not on it, the perpendicular line segment is the shortest. This is now the statement. On the basis of statement, the diagram of the question will be like this. There is a line. Consider this to be a line. Suppose line L, we'll call it. This is the given line. And a point is there, not on the line. There will be infinitely many points on the line. But we have to use a point which is not on the line. Suppose here is a point. A point A, this is the given point, which is not on the line. Not on it refers to this, that the point should not be on the line. Now, line segments are drawn there. How do we draw those line segments? By joining this given point to the different points which are on the line L. This is what the statement means. All the line segments drawn from a given point to the given line. So what shall we do? We'll mark some points on the given line L. Suppose these be few of those infinitely many points. I shall name this point as B, this point as C, this as D, this as E. Now line segments will be drawn. One of the line segments will be AB line segment. It has two definite endpoints. A is one of the endpoints, given point, and B is another endpoint which is on the line. Another line segment will be AC. Another line segment will be AD. And another line segment will be AE. These are some of those line segments. There can be many more. These are some of them. Out of these, let us consider AD to be the perpendicular segment, such that this angle is 90. So of these 4 line segments that we have drawn by joining the given point to the points on the given line, AD is the perpendicular segment. The remaining segments AB, AC, AE are not perpendicular because they do not make angle of 90 on the line L. We have to prove this perpendicular segment is the shortest. That is the diagram of this question. Now quickly I shall tell you the given and to prove of this. You write given. A line L and a point A. Bracket mein, we will write in the bracket, not on L. After the A alphabet, you write not on L. Full stop. The line segments AB, comma AC, AD and AE are drawn such that AD is perpendicular to L. This will be a given part of this. And then you write to prove. What do we have to prove? That this perpendicular segment is the shortest. The name of the perpendicular segment here is AD. So write to prove AD is the shortest segment. To prove AD is the shortest segment. Let us prove this result now. Here is the proof for this. We know AD is perpendicular to L. This is given to us. This means the angle formed at point D will be a right angle, 90-degree angle. Therefore, angle ADB is equal to 90 degrees. Now when this is a right triangle, therefore angle ADB is 90. That means triangle ADB is a right triangle. Is a right triangle. A triangle having one angle equal to 90 is called a right triangle. So ADB is a right triangle. Likewise, we can show ADC is a right triangle. ADE also is a right triangle. And if you draw any other line segment also, those also will form right triangles with AD. AD I am using common in all the triangles because we know AD is perpendicular to L. So I said ADB, ADC, ADE and likewise others. All those will be right triangles. Let us first for the time being consider ADB right triangle. We'll write results similarly for the others later. In our question number 1 of this exercise, we proved hypotenuse is the longest side of the right triangle. Look at this right triangle that we have got. ADB, this is the one. A is here, D is here, B is here, this is right angle. Now in this right triangle, AB is the hypotenuse. Therefore, according to question number 1, which we have already proved, AB will be the longest side of the 3 sides of this triangle. AB will be then larger than AD. It will be larger than BD also. And out of those, BD is not the line segment drawn from A to the line. BD is the part of the line L. We'll therefore ignore this BD. We'll use only the line segments drawn here by joining A to the line, points from the line L. Those are AD and AB. And out of these, AB is larger than AD. Therefore, triangle ADB is a right triangle. So what will we conclude? Therefore, AB is larger than AD. AB is larger than AD. And the reason is, right, because in a right triangle, hypotenuse is the longest side. Hypotenuse is the longest side in a right triangle. Now when we say AB is larger than AD, that will in turn mean AD is smaller than AB. So we write or AD is shorter than AB. This is the first result. You mark it first. We got it from one of the triangles formed with this AD, which is perpendicular segment. Now, if similarly we use another right triangle there, ADC. Instead of ADB, now I have ADC. This time AC will be the hypotenuse instead of AB. Now AC will be the hypotenuse. By using the same procedure, hypotenuse is the longest side. We'll say therefore AC is larger than AD, and in turn it will mean AD is shorter than AC. We'll write similarly. AD is shorter than AC. This is second result got from second right triangle, and there is third right triangle also, where from we'll get AE is shorter than, AD is shorter than AE. Mark it number 3. We find AD is common in all these three results. AD is shorter than AB, AD is shorter than AC, AD is shorter than AE also, which means AD is the shortest of all these segments that we have drawn. We have here drawn how many segments? 4. Out of all these 4, AB, AC, AE and AD is the shortest segment. So you write, conclude, let us conclude this from first, second and third we have. All of you write, from first, second and third we have AD is the shortest segment of all the segments drawn from a given point to the given line. With that, this chapter is over. I will begin another chapter. This chapter was chapter number 6. We shall now begin chapter number 7 of your textbook. It is quadrilaterals. Quadrilaterals. Chapter number 7 of your textbook. The introduction of quadrilaterals. You have already read about quadrilaterals in earlier classes. Quadrilateral is a polygon with 4 sides. Is called a quadrilateral. Polygon with 4 sides is called a quadrilateral. This is the diagram of a quadrilateral. It is a quadrilateral. It is a polygon with 4 sides. If we name this quadrilateral as A, B, C, D, then we shall say ABCD is a quadrilateral. Now we need not say it is a polygon. Its special name is quadrilateral, so we'll say ABCD is a quadrilateral. The quadrilateral has got 4 sides. You can name those 4 sides of the quadrilateral in this figure, in this quadrilateral. One of the sides is AB. Second is BC. CD is the third one. And DA is the fourth one. 4 sides of this quadrilateral. AB, BC, CD and DA. It has 4 angles also. The 4 angles are formed at the 4 vertices involved here. A is one of the vertices, B is second vertex, C is third vertex, D is fourth vertex. The angles formed at these vertices are the angles of the quadrilateral. Now short names of those angles will be angle A, angle B, angle C and angle D. These are the 4 angles. Short names of the angles I have written. Besides these 4 sides and 4 angles, a quadrilateral has two diagonals also. Quadrilateral has two diagonals also. Now you have read about diagonal in your previous class. Diagonal is that line segment which joins two non-consecutive vertices of the polygon. That line segment is called as a diagonal. Non-consecutive, which are not consecutive. Now A and B are consecutive vertices. When you join them, you get the side of the triangle. AB is the side of the quadrilateral. B and C are the consecutive vertices. When we join them, we get the side of the quadrilateral. BC is the side. A and C are non-consecutive vertices of the quadrilateral. These are not consecutive vertices. These are non-consecutive vertices. Likewise, B and D are the non-consecutive vertices. So when we join A to C, dotted line I have drawn to join them, a line segment is obtained. This is called as the diagonal. So two diagonals are there. AC is one of the diagonals. Second diagonal will be BD, obtained by joining non-consecutive vertices B and D. So AC is the first diagonal and BD is the second diagonal. Four sides are there, four angles are there, two diagonals are there. When we add all these, 4 plus 4, 8 plus 10, 8 plus 2 becomes 10. There are 10 elements on the whole. A quadrilateral has 10 elements. You have earlier read in case of triangle, a triangle has 6 elements. Those include 3 sides and 3 angles. We don't have any diagonal in case of a triangle, because in the triangle we have only consecutive vertices. We do not have any non-consecutive vertices in the triangle. Therefore, triangle does not have any diagonal. A quadrilateral has 10 elements on the whole. Those include 4 sides, 4 angles, and 2 diagonals. Then you have read the quadrilateral can be a convex quadrilateral or a concave quadrilateral. In class 8 you have read. A quadrilateral can be a convex quadrilateral or a concave quadrilateral. Just to refresh, a quadrilateral is called convex if both the diagonals lie completely in the interior of that quadrilateral. If when you join the diagonals, you draw the diagonals, no part of the diagonal lies outside the quadrilateral, then it is called convex. For example, look at this quadrilateral, again the one we have earlier drawn. Consider this. ABCD, I shall again name it. This is the interior of the quadrilateral, which lies within the 4 boundaries, 4 sides. That part is called interior. And this is the exterior of the quadrilateral. This whole thing is the exterior of the quadrilateral. Now, as we join the 2 diagonals, this is the first diagonal. Look at this, it completely lies in the interior part of the quadrilateral. Second diagonal we draw, this also lies completely in the interior of the quadrilateral. No part of the 2 diagonals lies in the exterior part of the quadrilateral. These both diagonals lie in the interior. Therefore, this quadrilateral is called as convex quadrilateral. On the other hand, I have a quadrilateral here. This is also a quadrilateral, 4-sided polygon. This also is a 4-sided polygon. Now, being a quadrilateral, this will also have 2 diagonals. One of the diagonals here will be AC, non-consecutive vertices we join A to C. This diagonal lies completely in the interior again, like this one. lies in the interior. But when we draw this diagonal, B to D we join, it lies in the exterior of the quadrilateral. Now when that is the situation, then the quadrilateral is called concave quadrilateral. So this quadrilateral ABCD is a concave quadrilateral, this quadrilateral ABCD is a convex quadrilateral. Then you have read again in class 8, a quadrilateral can be a regular quadrilateral or an irregular quadrilateral. Now what do we mean by regular quadrilateral? Against that, then we'll have irregular quadrilateral. By regular quadrilateral, in general regular polygon, here it is regular quadrilateral. We mean quadrilateral whose all the sides are of equal length and all the angles are of equal measure. Angles are of equal measure. Sides are of equal length. Now when this will be the situation, we have just now seen a quadrilateral has 4 sides. If all those 4 sides are of equal length, if one side is 3 centimeter, remaining sides also are of 3 centimeter length. All the sides are of equal length. And all the angles are of equal measure. One angle, second angle, third angle, fourth angle. 4 angles are there. All of them are of equal measure. Then the quadrilateral is called a regular quadrilateral. And such a quadrilateral, a regular quadrilateral, is given a special name. It is called a square. Square is a regular quadrilateral. Well, now if these conditions are not fulfilled, both these conditions, maybe only one is fulfilled, the second one is not fulfilled, maybe both are not fulfilled, then that quadrilateral will be called as irregular quadrilateral. Look at rhombus you have read, rectangle you have read. Rectangle has all angles of equal measure, 90, 90, 90, 90, all the 4. But all the sides are of not equal length. Only opposite sides are of equal length. Therefore, that cannot be called as a regular quadrilateral. Similarly, look at rhombus. All the sides are of equal length, but all the angles are not of equal measure. Therefore, that also is not a regular quadrilateral. A quadrilateral can be therefore a regular quadrilateral or an irregular quadrilateral. It is regular quadrilateral if all the sides are of equal length and all the angles are of equal measure. Then it is called a regular quadrilateral. Then we have read angle sum property of quadrilateral. Angle sum property of quadrilateral. Earlier we have read angle sum property of a triangle, and the result was proved also there. That was a theorem there. We proved sum of angles of a triangle is 180 degrees. That is angle sum property of a triangle. Now we have angle sum property of a quadrilateral, but we need not prove it here. You have to remember only the statement. The statement is sum of all angles. Sum of all angles of a quadrilateral is 360 degrees. By 360 degrees, we mean 4 right angles. One right angle is 90 degrees, 4 right angles becomes 360. The sum of all angles of a quadrilateral is 360 degrees. This is angle sum property of a quadrilateral. Well, having said this, we next have consecutive sides and opposite sides. Consecutive sides and opposite sides of quadrilateral. I shall again draw the rough diagram at quadrilateral. For example, A, B, C, D. It can be convex, concave, regular, irregular. This is the quadrilateral. We have already read it has 4 sides. We have here consecutive sides and opposite sides. So only 4 sides will be used. 4 angles are there, 2 diagonals are there. Will not touch those sides only. 4 sides are there. Now out of these 2 sides which have one endpoint common. For example, AB and BC. These have one endpoint common. B is the common endpoint of these. Those 2 sides which have one endpoint common are called as consecutive sides. AB and BC are therefore consecutive sides. We also have BC and CD as consecutive sides. This time C is the common vertex, common endpoint. CD and AD also are the consecutive sides. AD and AB also are the consecutive sides. These are consecutive sides which have one endpoint common. AB and BC, consecutive sides. BC and CD, CD and AD, AD and AB, consecutive sides. Against this we have opposite sides. 2 sides of the quadrilateral which do not have any endpoint common are called as opposite sides. AB has 2 endpoints A and B. If I ask you out of the 4 sides, which other side of this quadrilateral neither contains A nor B? If you call BC, it contains B. It is the consecutive side. They have endpoint common. If you name AD, this AD again is the consecutive side of AB because A is now common. There is only one such side, CD, which does not have any endpoint common with AB line segment, AB side. AB and CD therefore are opposite sides. They do not have any endpoint common. Such sides of the quadrilateral which do not have any common endpoint, those are called opposite sides. AB and CD are opposite sides. BC and AD are opposite sides. Whereas if one endpoint is common, then those are called as consecutive sides. Now similarly, we have consecutive angles and opposite angles of quadrilateral. While identifying consecutive sides and opposite sides, we found whether they have common endpoint or not, common vertex or not. Well, in order to identify consecutive angles and opposite angles, you have to find arms of angles. Angles have arms. And if the 2 angles have a common arm, then those will be called as consecutive angles. Like here, in case of consecutive sides, they have common, one endpoint common. Likewise, if they have one arm common, those will be called consecutive angles. And if they do not have any common arm, those will be called opposite angles. Look at angle A. Its arms are AB and AD. Then look at angle B. Its arms are AB and BC. AB is their common arm. Angle A and angle B are such that they have one arm common. Now in such a situation, we call angles consecutive angles. Therefore angle A and angle B are consecutive angles. Similarly, you can say this angle B and angle C, these are consecutive angles because these also have a common arm. BC is their common arm. Angle C and angle D are also consecutive angles. Angle D and angle A are also consecutive angles. because they have common arm. And if they do not have any common arm, then we call them opposite angles. Think about angle A and angle C here. Name angle, arms of angle A. We have already called AB and AD are the two arms of angle A. What about angle C? Its arms are BC and CD. We don't have any common arm here. AB is not common. AD is not common. Such angles are called opposite angles. Definitions are same. Here you have to find common endpoint. If they have, then those will be called consecutive sides. If they do not have, those will be called opposite sides. Whereas in case of consecutive angles and opposite angles, you have to find out common arm. If two angles have a common arm, then we'll call them consecutive angles. If they do not have any common arm, we'll call them opposite angles. Now that will do for this day. I shall move from there onwards next time. All the best.